Okay, we are going to continue here into chapter 7, working with polynomials. We are on day 4. We're going to be multiplying polynomials again today, but today we're going to be doing a binomial times a trinomial. Okay, so when we look at this, it's going to be very similar to a monomial times a polynomial, my two binomials together, and now we're just going to do a different form of it. When we look at these problems, we are still basically using distributive property over and over and over again. So when we look at this process, I have just a generic form over here. What we're simply going to do is we're going to start off with this A right here. And we take that A and we're going to multiply it to C. We're going to multiply it to D. So I have AC. I have AD. Then I'm going to multiply it to E. Then I'm going to come back. I'm going to take the B, make sure you include that sign, and I'm just going to repeat the process. So I'm going to go B times C. I'm going to do B times D, and then I'm going to do B times E. And then at that point, I would look for like terms, whatever I have, and then I would finish off by making sure I'm written in standard form. And that is the process to multiplying a binomial to a trinomial, a binomial to a polynomial. It doesn't matter what else we give you now at this point. Just remember you're using distributive property over and over and over again until everything is multiplied by everything. Okay, now I also wanted to show you another technique we've been working with, but I want to show you the technique also using Punnett squares. Now, what a Punnett square does is it helps you organize your work a little bit just to make it a little more, organized is probably the best word I'd use, I guess. So what we do is we take the 2x and the 3 from the first one, and I'm going to write 2x on the first line there. And then I'm going to write plus 3 on the second line. Then across the top, this is where I'm going to take my 3x squared, my positive 4x, and my positive 5. Now, what I simply do is I just multiply going across. So 2x times 3x squared, that's going to give me 6x to the third. Remember that you're adding those exponents. Then I go to the next square, 2x times 4x, that gives me 8x squared. Then I go to the next square, 2x times 5, that gives me 10x. Then I drop down to the second row. So I have 3 times 3x squared, that's 9x squared. 3 times 4x, that gives me 12x. And then 3 times 5, that gets me 15. Now, when I go to write my final answer, what we simply do is we look for our like terms. So I start off 6x to the third. Nothing is alike to it. No other x to the thirds. So that one's there. My next one that I look at is I have these x squared terms. So I add those together. So 9 plus 8 gives me 17x squared. Then I look, do I have any other like terms? And I do. I have 12x and 10x. So I would simply add those together, and that gives me 22x. And then the last one, I have 15, and nothing is alike to the 15. So I just bring that down as plus 15. And if you notice, I'm written in standard form. I've combined all my like terms, and there it is. Okay. So on these next two problems, what I'm going to do is I'm going to show you both techniques, and then you can decide which one you like better. I do not have a problem, whichever one you do. So we're going to show both, and then we'll go from there. Okay, so the first one I'm going to do is I'm going to take the x, and I'm going to multiply it to everything. So I go x times 5x squared, and that's going to give me 5x to the third. Then I do x times 3x, and that gives me 3x squared. Then I do x times 6, and that gives me 6x. Then I come back, and now I'm going to take the positive 2, and I'm going to multiply it through. So I'm going to go positive 2 times 5x squared, that's 10x squared. I'm going to take the positive 2 times the 3x, that's going to get me 6x, and then I do the positive 2 times 6, which is 12. Now my last step is I look for like terms. So I start off, I have 5x to the third, nothing else is alike to it, so I have 5x to the third. Then I look, or do I have any other like terms? And I have 3x squared, and I have a positive 10x squared. So 3x squared plus 10x squared, that's going to give me 13x squared. Then my next one I'm looking for is I look for my x's. I have 6x and 6x, and that's going to get me 12 x's. And then you'll notice down here on the very end, I have this plus 12, nothing alike to it, and I put that on the end, and there is my answer. Now, just to show this exact same thing using the Punnett square, I'm going to do it here on the side. So I'm going to start off, I have x here, I have a plus 2 here. Across the top, I have 5x squared, I have the positive 3x, and I have the positive 6. So now we just go square to square, so x times 5x squared, that's going to get me 5x cubed. X times 3x, that's going to get me 3x squared. X times 6, that's going to get me 6x. Then I go 2 times 5x squared, that's going to give me 10x squared. 2 times 3x, that's going to give me 6x. 2 times 6, that's going to get me 12. So now I start looking. So I start here at the beginning and I go 5x to the third. I look for like terms, so I have 10x squared and 3x squared. That's going to give me 13x squared. I look again and I have 6x and 6x, and that's going to give me plus 12x. And then my last one there is plus 12, and there's nothing alike to it, so I just have the plus 12 on the end. If you notice, both of them, you are getting the exact same answer. It's just different process as far as organizing your work. And like I said, you are welcome to do either of those methods. As long as you show your work, I do not have a problem with either one of those methods. Okay, so let's try again. So we're going to start off here with the 3x. So we're going to take the 3x and we're going to times that to 2x squared. So that's going to give me 6x to the third. Then I take the 3x times the negative x, and that's going to give me negative 3x squared. Then I take the 3x times the negative 5, that's going to give me negative 15x. Then I come back and I take the negative 8. So I'm going to go negative 8, that's going to give me negative 16x squared. And then I do the negative 8 times negative x, and that's going to give me a positive 8x. And then I take the negative 8 times the negative 5, and that's going to give me a positive 40. Now we look for like terms, so I'm going to start with my 6x to the third. Nothing is alike to it. Then I look for anything else. I have x squareds, so I have a negative 16, and I have a negative 3, so that's going to give me a negative 19x squared. Then I look for my x's. I have a negative 15 and a positive 8, so that's going to give me a negative 7x. And then my final one here, I've got a positive 40, nothing alike to it, so it would give me plus 40. And I would have it written in standard form, and I've collected all the like terms. Okay, let's try the same thing using the Punnett square. So I'd have 3x in this box, I'd have negative 8 here, and then I have 2x squared across the top. I have a negative x, and I have a negative 5. So 3x times 2x squared, that's 6x to the third. 3x times negative x is negative 3x squared. 3x times negative 5 is negative 15x. Then I drop down to the negative 8. So negative 8 times 2x squared is negative 16x squared. Negative 8 times negative x is a positive 8x. and negative 8 times negative 5 is a positive 40. Then we start in, we just rewrite it. So I start with my 6x to the third, nothing to combine that with. My first grouping that I'm looking at is I have my x squared terms. I'm going to put those together, and that gives me negative 19x squared. Then I look for my second one. I have an 8x and a negative 15x, and that's going to get me a negative 7x. And then the plus 40 there on the end, nothing alike to it, and that would be my answer. And that is how we end up multiplying a binomial to a trinomial, or we could multiply it to any number of term polynomial. We just do the same process, repeating that distributive property until we've multiplied everything to everything.